Hi everybody, we're going to work on the last 5 of your SAT problems, 16 through 20. They're going to be the open-ended ones. I want to go through these with you because there's some good math and techniques on this that I want you to know for your test. 16. If t is greater than 0, so right away we know that t has to be positive because it's greater than 0. So we got to keep that in mind. That's kind of an important piece to this. And then it says and, so it's t is positive and t squared minus 4 equals 0. What's the value of t? So we add 4 to both sides. T squared equals 4. So what we do is take the square root. So t is equal to the square root of 4. T is equal to plus or minus 2. Meaning it's either 2 times 2 is 4, negative 2 times negative 2 is 4. But t has to be greater than 0. So the answer to this is t is equal to 2. Okay? So, again, another type of problem that you should be able to get. Just got to kind of know both things on that there really is only one answer to these open-ended ones. And we'll deal with filling in the blank piece as part of class, because we did this the other day. Remember we did the filling in the bubble sheet. That's what you're going to have to do for these. Okay, so there's that one. The next one's a good one. Number 17. We have this, although it is a little bit kind of different scale-wise, but the scale doesn't really matter for this. But we're dealing with similar triangles. And it talks about finding the length of x with all sorts of things happening. When you do the math, you'll fill in the given information. You'll know that that's 1800, that this is 700, that this is 800, and this is 1400. We know that these angles are congruent because vertical angles are congruent, if you remember that from your geometry classes. It also tells you that this angle E and this angle D are congruent. So if these two are congruent, we've got kind of some similar triangles going on here on this. And so that if these two are congruent, that means that's going to be congruent there. All right? And if that's the case, the triangles are similar, meaning their ratios are the same. So this angle, this side is between the one we have 1 and then 3. Notice how it's between kind of the 1 and the 3, meaning this one's between the 1 and the 3. So this side and this side are going to be proportionately the same. So what do we know, though? We know that between the 1 and the 2, 700, and the 1 and the 2 is 1400, so that this and this have to be are half of each other. So that means the relationship from here to here is going to be this is half of this, and that this is half of this. The similar triangles, the relationship we're seeing is that each of these sides is half the length here, so this is going to have to be 1600. And that's your answer to this problem. You might want to go back and watch this part again, because it's a pretty good problem. You'll see geometry problems that involve similar triangles. 18. 18, folks, you have a graphing calculator and you can do a system This one should be easy. I'm not even going to do the whole problem. Do a matrix, 1, 1, negative 9, 1, 2, negative 25. When you do RREF as part of your matrix, you'll get, remember we get those as our answer, and then you're going to get negative 16 here, but you're going to get 7 here. And they ask you what x is, and that's our x term right there, so x is 7. (19) deals with right triangles. It deals with trigonometry, and you haven't done a lot of trigonometry unless you had CP geometry last year. We have a right triangle, so it says in a right triangle, one angle measures x degrees. So we're going to say this is x, where the sine of x is 4 over 5. And so that the sine is 4 over 5. What that means is that sine is equal to opposite over hypotenuse. So that the opposite is going to be 4 over 5. What's the cosine of 90 minus x degrees? Well, if this is x, this angle right here is 90 minus x. And cosine is equal to adjacent over hypotenuse. And so if we're dealing with the other angle, and we're dealing with adjacent, that's the same as opposite for the x. So for adjacent, it's 4 over 5. So our answer is 4 over 5. And you would write that in the bubble sheet as 4 over 5. This one's going to be hard for those of you that haven't had your trigonometry. And we do that as part of this class later on in the year. So you may or may not be able to do 19 if you see one like that. 20. Last one. Definitely one you can get. The trig ones, you don't get them, you don't get them. But for 20, you should be able to get 20. And so it says if a equals 5 times the square root of 2, and 2a equals the square root of 2x, what is the value of x? So, well, let's do something first. A equals this. 2a means double this. And I'm not sure if you remember from Algebra 1, when you double this, you will get 10 times the square root of 2. So 2a equals 10 times the square root of 2. So that's going to equal this. So now we've got to figure out, well, what's the square root of 2x? If we have a 10 here, that means inside we had to have 10 squared to go inside here, because to pull this out, we have to have 100 in here. And here's what I mean. The square root of 2 times 100. The square root of 100 is 10. So when we have that, the square root of 2 times the square root of 100. And the square root of 100 is 10 times the square root of 2. And that's what we have right here. So we're kind of going backwards on this to fit this in. So to get 10 here, we had to have 100 inside the radical. So that means here, this would be 100. So really, all they're asking in this problem, in a long process way, is what's 10 squared to get your answer. So our answer for this is x equals 100. If you need to go back and watch some of these, I highly encourage it with your radicals and your trigonometry.